Here we are at example 8 from our 2.4 set of notes. We're asked to use the quotient rule to find the following derivative. We notice that we actually have a rational function here, so we're going to go ahead and set the top equal to f and our bottom equal to g. So then off to the side we have f is equal to 1 minus the cosine of x, and our g is going to be equal to the sine of x. Now, when we're trying to take the derivative of f, we're going to go ahead and take this piece by piece. So the derivative of f, it comes out to be, the derivative of this constant is 0. Now, the derivative of negative cosine of x, well, really there's a negative 1 in front of the cosine of x. And we know that with our properties with derivatives that we can take this constant negative 1, throw it in front of the derivative, and as a result you would end up then with negative 1 times the derivative with respect to x of just the cosine of x. And as a result, the derivative of cosine of x we've talked about, that comes out to be negative sine of x. So just this part comes out to be negative sine of x. So then f prime comes out to be negative 1 times negative sine of x, which then just gives you a positive sine of x when you multiply it by the negative 1. So in all, f prime will come out to be positive sine of x. For our g, he's actually not too bad. When we take the derivative of him, derivative of sine of x just comes out to be cosine x. Now we can go ahead and do our cross. So we end up then with f prime of x is equal to the sine of x times the sine of x, big minus, using the quotient rule again, our f times g prime. So 1 minus cosine of x times cosine of x. And again, because we're talking about the quotient rule, this is all over our g squared. So sine of x squared. Cleaning this up just a little bit more, we end up then with sine of x times sine of x gives us sine squared of x minus, we'll go ahead and distribute this cosine of x into both terms. Then as a result we would end up then with cosine of x minus cosine squared of x all over sine squared of x. Going ahead and distributing this negative into both terms, we end up then with sine squared of x minus cosine of x plus cosine squared of x all over sine squared of x. Now we can go ahead and just basically flip these two numbers. So we're going to put the cosine squared over here and the negative cosine at the end. Then we end up then with sine squared of x plus the cosine squared of x minus the cosine of x all over the sine squared of x Now, back from pre-calc, we learned that the sine squared of x plus cosine squared of x came out to be just 1. So this entire top piece just comes out to be 1 minus the cosine of x all over the sine squared of x. Now, believe it or not, we can actually even simplify this even further. The sine squared of x is the same thing as saying 1 minus the cosine squared of x. And it's extremely subtle as to why we would do this, but if you can see it, we can go ahead and substitute in this 1 minus cosine squared of x factor, and then get something to cancel out. So we're actually going to go ahead and keep continuing to simplify this. We have 1 minus cosine of x on top, all over our 1 minus the cosine squared of x. Again, we could factor, really this is the difference of two perfect squares. So then we end up with still 1 minus cosine of x on top, all over, on the bottom, factoring this, we end up with 1 plus cosine of x times 1 minus the cosine of x. And now you can see these actually end up dropping out. So then we end up with 1 on top over 1 plus the cosine of x. So this would become our derivative with respect to x. Again, that is example 8 from our 2.4 set of notes.